Right, now we are on question 4. Question 4. Okay, our statement there. The graph of g of x is equals to ax cubed plus bx squared plus cx. A cubic function having a y-intercept of 0. So we know that our y-intercept is 0. It is drawn below. The x-coordinates of the turning points of G are -1 and 2. Those are our x-coordinates of the turning point. -1 and 2. All right, and then now question 4.1. For which values of x will G increase? Will G increase? I think this one is a straightforward one. Let's just answer the question, answer it right next to the question there. This will happen where? This will happen between the turning points. You see, between the turning points, our function is increasing. It is sloping upwards. So, for question 4.1, we will say the values of x for which the function increase, it will be where x is less than 2 but greater than -1. Or you can even write it in what? In interval notation. If you don't write it in this notation, write it in the interval notation to say x is an element of values from -1 to 2. That will be our solution in interval notation. Then question 4.2, write down the x coordinate of the point of inflection of G. Remember, for us to find the x coordinate of the point of inflection, we must find the second derivative equate to 0 and solve for x. But at this stage, we will not be able to do that. As our equation of g of x, it is still having the parameters a, b, and c, of which we do not know their values. Therefore, we need to use what? Another approach. But we also know that to find the x coordinate of the point of inflection, we take what? We take the x coordinates of the turning points, we add them together, and then we divide by 2. Therefore, for question 4.2, we will say x will be equals to x coordinate of the turning point minus 1 plus the x coordinate of another turning point 2, all divided by 2 is equals to 1 over 2. Now 4.3, for which values of x will G be concave down? Will G be concave down? So let's say our point of inflection will be somewhere here where x is 1 over 2, the x value of the point of inflection. So where are we going concave up? Where are we having concave down? We know that on the left of the point of inflection, you see this is concave up, and on the right of the point of inflection, it is concave down. Therefore, concave down will be where? It will be where x is greater than 1 over 2. Therefore, here we'll say it will be where x is greater than 1 over 2. Then question 4.4. Solutions, we will do 4.4 here. 4.4, it says if g prime of x is equals to -6x squared plus 6x plus 12, determine the equation of g. Where is g? Here is g, meaning here is g, meaning determine the what? Determine the values of the parameters a, b, and c. I'm sure you understand why we are not having d. We were told that y-intercept is what? Is 0. Therefore, our d is equals to 0. Okay. Then What are we given? We're given the equation of the what? Of the gradient of g. So let's find the gradient of g in general from the given equation. We'll see, firstly, we have g of x is equals to ax cubed plus bx squared plus cx. Then g prime of x will be equals to 3ax squared plus bx plus c. But we're given the equation of what? G prime of x. It is what? But we know that g prime of x is also given by negative 6x squared plus 6x plus 12. Therefore, we know that what? To determine the values of what? A, B, and C. Then we say what? We can say, let's label this 1, let's label this 2. Then let's compare. We are going to compare the what? The coefficient of x squared, the coefficient of x, and what? The constant number. So we are not solving the two equations simultaneously. I've just labeled them 1 and 2 so that you can understand which one I'm talking about. So from equation 1, the coefficient of x squared is what? Is 3a. Then it must be equals to what? The coefficient of x squared in equation number 2, 6. And then from there, solve for a, divide both sides by 3, we get a is equals to minus 2. Then in equation 1, the coefficient of x is b. It must be equals to the coefficient of x in equation number 2, which is 6. Therefore, b is equals to 6. And then the constant number in equation number 1 is c, and it must be equals to the constant number in equation number 2, which is 12. Therefore, now we can say g of x is equals to, what is a? Minus 2x cubed plus b, what is b? Plus 6x plus cx, what is c? Plus 12x. And this will be our equation of g. And then question 4.5, determine the equation of the tangent. Determine the equation of the tangent to g that has the maximum gradient. Write your answer in the form y is equals to mx plus c. Right. Question 4.5. Question 4.5. Let us go back to our graph. We need to find the equation of a tangent to g that has a maximum gradient. Now, this is the graph of g. From this graph of g, I'm going to give a rough sketch of the graph of the gradient, which is what? G prime of x. So this is how you draw it. Very simple. We are having what? We are having -1 and 2 as the what? As the x coordinates of the turning point. And between -1 and 2, g is what? Is increasing. Therefore, it means what? It means our gradient will be positive, where g is what? Is increasing. Therefore, it means what? The graph of the gradient will be on the positive y-axis. Then we also have what? The x value of what? Of the point of inflection. The x value of the point of inflection will be what? Will be the x value of the turning point of the gradient of g. Therefore, this will be the part of the graph. Then we have a turning point there, then it goes down here. Then this will be our turning point, where the x value is what? Is half. Then you will see from -infinity to -1, the graph is what? The graph is decreasing. Therefore, that is where the gradient is what? Is negative, meaning the gradient graph should be on the negative y-axis. Then also you see that from +2 to +infinity, our graph of g is what? Is decreasing. Therefore, again, in that interval, that is where the gradient will be what? will be negative, meaning the graph of the gradient should be on the what? On the negative y-axis. Then we say this is the graph of g prime of x. Now the question said what? We need to determine what? The equation of a tangent to g that is having a what? A maximum gradient. Where is the maximum graph? I mean the what? The gradient graph. Here is the gradient graph. The red one is our gradient graph. Where will the gradient be a maximum? It will be a maximum where? At the turning point. Therefore, what is the x value there? The x value is half. Therefore, it means what? We want the gradient at what? At x is equals to 1 over 2. Then, remember, we need to find our equation in the form what? Y is equals to mx plus c. Therefore, what do we need? We need m, the gradient, and then we also need what? At least another point, so that we'll be able to find the value of what? Of c. So, let's start first by finding the what? The gradient. At what? At half. That is where the gradient will be what? The maximum. Then we say g prime of 1 over 2 is equals to, then we substitute 1 over 2 into the equation of what? Of the gradient. So we say negative 6 into 1 over 2 squared plus 6 into 1 over 2 plus 12, which will be equals to, then this will give us 27 over 2. Therefore, m is equals to 27 over 2. Then now what do we need? Now we need a what? A point of contact. We need the y value when x is equals to half. Therefore, we substitute in what? In y, which is what? G of x. Now we need g of 1 over 2. And then we substitute in now in the equation of g. Minus 2 into 1 over 2 cubed plus 3 into 1 over 2 squared plus 12 into 1 over 2. And this will give us 13 over 2. Therefore, the point of tangency will be what? Our point of contact. Which is the point of tangency? It will be where x is 1 over 2 and where y is 13 over 2. And then from there, now that we have a point of contact as well as the gradient, we are now ready to find the what? The equation of a tangent. Then we can use this equation, y minus y1 is equals to m into x minus x1, where x1 and y1 will be x value of the point of contact and y value of point of contact, and then m is our gradient. Therefore, we say y minus 13 over 2 is equals to 27 over 2 multiplied by x minus 1 over 2. Then we get y minus 13 over 2 is equals to 27 over 2x, 27 over 2x minus 27 over 20, not 27 over 2x, but rather 27 over 2x multiplied by minus 1 over 2. It should give us minus 27 over 4. And then add 13 over 2 on both sides. Y is equals to 27 over 2x minus 1 over 4. Then that will be the end of question. Question 4.